What we're going to start with here is some topics involving real numbers. Okay, so real numbers are numbers that are aligned with numbers on a number line. So if you can represent a number somewhere on a number line, right, it falls within the scope of real numbers. So these represent real numbers here. Anything in between them also represents real numbers. So pi falls somewhere over here. It's still a real number. Any fractions fall in between. Anything to the right of 0 is positive. Anything to the left is negative. 0 itself has neither positive nor negative sign associated with it. Okay? But there's a set of subset of numbers that you need to be familiar with. And you're going to be categorizing in this. And so we're going to start with the least, the most exclusive, and work our way out. And so we're going to begin with natural numbers. Okay, so natural numbers are just the counting numbers starting at 1. Okay, so 1, 2, 3, and so on. Okay, the ... just represents that they extend infinitely in that direction. Okay, but 1 is the smallest of the natural numbers. Okay, once you extend beyond that, there's another set of numbers that you can look at, and that is whole numbers. Okay, so whole numbers, notice I put this block around the natural because whole numbers are going to include all of the natural numbers as well, with the addition of 0. So notice where the brackets are located here. It's 0, 1, 2, 3, blah, 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 all the numbers that fall after that as well. Okay. Once you get past the whole numbers, we're going to take their opposites as well. And when you look at those would be represented by integers. Okay, so integers are the set of all natural and whole numbers. Those are still included within them. Okay, but in addition to that, it's all of the negatives too. So I'll put the ... here to represent this goes on infinitely in the negative direction as well, but it's -3, -2, -1, 0, 1, 2, 3, 4, all that extend out. Okay? So those all fall into the category of integers. Okay? The last sort of category that sort of encompasses all of these is going to be rational numbers, which are designated with the letter Q. Okay? Rational numbers are represented with a Q. And rational numbers are any number that can be represented as a fraction of two integers. Okay, so this is the fraction of m over n, as long as n doesn't equal 0. Okay, you can't have division by 0. Okay, and the indication is that these m and n's come from the integer set. Okay, so if you can recreate, if a rational number exists, it can be written as a fraction of two integers. And now, in addition to these, so rational numbers include a number of different things beyond just the integers. But again, you can see it encompasses these integers as well. Okay, so rational numbers include any fractions, so things like 5, 6, -2/3. Any kind of fractions are included in rational numbers. Any repeating decimals are also considered rational numbers. So 0.5 repeating, if it has a bar over it, indicates repeating. You might also see repeating as some pattern with the ... That indicates that this pattern of 1, 2, 1, 2, so it's a pattern of 2 digits repeating, right? Not 4, but once you see a pattern established in the ... that represents the repeating decimals. Okay? And then also, it's any terminating decimals. Okay? So terminating decimals would just be like 0.35, -5.1. If it ends, it can be expressed as a fraction of two integers. Right, now, in addition to these rational numbers, which again can also be categorized more fully into integers, whole numbers, and natural numbers, and there's also a set of what are called irrational numbers. Okay? Irrational numbers are designated with Q prime. Okay? So it has Q. It's a Q with a little apostrophe. Okay? That's your set of irrational numbers, and these are numbers that cannot be expressed using the fraction of two integers. Okay? So this includes things like pi, which is an irrational number, e, which is an irrational number, and any variation of those. It also includes square roots or any kind of roots that can't be simplified into a whole number, okay? So, or an integer value. So the square root of 2 is irrational, positive or negative. Root 3 is irrational. What about root 4? What category would root 4 fall into? Root 4 simplifies to 2, so it's a natural, a whole, an integer, and a rational. Okay? And so these are the different number sets that you are going to be looking at. They all are encompassing the real number. So everything that fits into this slide here is considered a real number.